Hi, we're still talking about laboratory safety, and in this video, we want to talk about risks and hazards. To do so, we want to learn an acronym. First off, RAMP, R-A-M-P. R, recognize the hazards. A, assess the risks of those hazards. M, minimize the risk of those hazards. And P, prepare to respond in emergencies. RAMP. Recognize hazards, assess the risks, minimize the risks, prepare to respond. So R, recognize hazards. Hazards and risks are not the same. A hazard causes harm, and a hazard can be eliminated but not reduced. There are all sorts of hazards. Chemical hazards, biological hazards, cuts, electrical hazards, falls, fire, mechanical hazards, noise. There's ionizing and non-ionizing radiation, and thermal hazards within the lab. You can get burned. And so there are all sorts of hazards that we encounter in the lab. And you might remember from another video talking about the GHS, the Global Harmonized System, the pictograms, when we're talking about different reagents, that they could be explosive or flammable or oxidizers. We can be dealing with compressed gas. Reagent chemical substances could be harmful, could be an environmental hazard, a health hazard, corrosive, or toxic, poisonous. So R is to recognize the hazard, and so may well fall in one of those categories we just looked at. A is for assess the risks. Now, risk is the probability that a hazard will cause harm, and risks can be reduced. So the risk is equal to hazard times the exposure. And so the little cartoon that you see are some people sunbathing at the beach, and the hazard is the sun and the ionizing radiation from the UVA and UVB radiation. And you see the folks that aren't underneath the umbrella. The guy that's laid out, he's getting pretty well cooked. Whereas the folks under the umbrella, they've reduced their risk. They are probably have some good sunscreen on, sunblock, and they're underneath the umbrella. The hazard's still there, the sun's still beating down, but they've minimized their exposure, thus reduce the risk. So a hazard is something that has the potential to harm you, and the risk is the likelihood of the hazard causing harm. So there are different ways of going about minimizing risk, and there's a hierarchy of controls. And the best way to minimize the risk is to eliminate the hazard, to physically remove it. If we can't do that, we substitute. We replace the hazard. Maybe a less toxic reagent. There are engineering controls that we can use that isolate people from the hazard. The glass panels in the exhaust hood would be an example for that. And there are administrative controls, changing the way that people work, getting them better training. But the first line of defense in minimizing the risk is your PPE. And so that's why we stress so much that you make sure that you got on all your correct PPE, that you're wearing it. Safety glasses, although these are prescription glasses, but you'd have on your safety glasses, your lab coat, long pants, proper shoes, socks. And the last letter is P, prepare to respond. Knowing where the sink is, the eye wash fountain, in case you got a spill or you need to wash something off your hands, or you had a splash on you. Got a spill, you go get the spill kit. A cut, get the first aid kit. Knowing where the exit is important, where the secondary exit is. Knowing where the electrical supply panel is, in case you've got an electrical fire going, for example, so that you can hit the breaker. And And so being prepared to respond is important. So RAMP. Recognize the hazards, assess the risks of those hazards, minimize the risks of those hazards, and prepare to respond in emergencies. So let's watch this little video from the American Chemical Society to finish us up with this video.
Remember when you first started doing research in the lab? Everything was so daunting. You had to think about every step and make sure you'd really thought it through. But now that you've done it 100 times, it's easy, right? It's like crossing the street. No problem. You could do it blindfolded. No. Even though it's the same street that's part of your daily routine, you always look both ways. Always. Your experiment, like the street, is in flux. Science that seems straightforward turns out to be fairly complex. Conditions change, and even routine experiments carry risks. By assessing these risks and preparing for foreseeable emergencies, you can make the lab safer. And doing a risk assessment makes you a better scientist. A hazard assessment will identify all the possible things that could go wrong. And a risk assessment is a priority list of these. Which are the most likely to present a risk? You've made a habit of looking both ways each time you cross the street. Make a habit of recognizing, assessing, and managing hazards, and preparing for emergencies. These steps are the foundations of a good risk assessment and the foundations of good science. I know what you're thinking. A risk assessment? There are always reasons why we become complacent. But I've only changed one thing. It's just another solvent, right? But I was only using a few drops of bromine. I've done this loads of times. I'm just scaling it up. I couldn't use the blast shield. Someone else was using it. But nothing has changed. But if I had done a risk assessment, I wouldn't have had time to set up the experiment. Don't worry, my colleague did a risk assessment, and I'm sure it was very thorough. Because both good science and lab safety require planning, preparation, and constant attention to changing conditions. Because you'd never say, I don't need to look both ways today. I did that yesterday.
So thanks for watching, and remember RAMP when you go into lab. And actually, before you go into lab, be thinking about all those things.